Hi, and thanks for watching lesson 3.2.2, which is logs as inverse exponentials. I'm not going to read this to you, but please make a note on your sheet that you do need to read this and be ready to answer questions on facts in here. All right, so we're just going to work through a couple of problems here. We're going to start with 3-67. 3-67 says to make a table like the one below and use any patterns you see to fill in the missing numbers. The reason it reads like that is because in the textbook, they're expecting you to copy this onto your own paper, but since I've made you a copy anyway, you don't need to remake this. You just need to fill this one in. Okay, so to use any patterns you see to fill in the missing numbers, I'm just going to highlight over the columns so that it stands out a little bit more for you. So looking at these numbers, hopefully you see that most of these are powers of 5. Most of these are powers of 5. For instance, one of them that's already filled out in here, 25, you know, is 5 squared. So if this is 5 squared, then hopefully you can see that the power is the value of y. Okay? So we can represent each one of these as a power of 5. Hopefully you remember that 5 cubed is 125. So if y is the power to which 5 is raised, then y should be 3 here. Notice that if you did 5 to the 0 power, then you would get 1, because anything to the 0 power is 1. Notice that 1 over 25 is 1 over 5 squared, and if I was going to write this in the numerator, then I would simply change the exponent to a negative, or an inverse. So this would be 5 to the negative 2, so the exponent here would be negative 2. Okay, let's see what else we have here. The 1/2 power, 5 to the 1/2 power. Remember that anything to the 1/2 power is the same thing as the square root. So 5 to the 1/2 power is the square root of 5. Okay. So 5 to the what power is 5? Goodness, I hope we know that one. So then the only one we have left here is, well, one of them we have left here is 1/5, which is 1 over 5 to the first power, which is 5 to the negative 1 power. So your exponent there would be negative 1. Okay. Is there any power that you can raise 5 to get negative 1 or 0? If not, then your answer here is simply none. Okay. Now looking at question B, and I know you can't see this down here, but you can see it on your own paper. This says to express x as a function of y. X is a function of y. Well, these x values are 5 raised to the y power with our values here. So x is simply 5 raised to the y power. Feel free to pause it or rewatch it if you need to. Push it up for just a second. Here we have x is a function of y. It's simply x equals 5 raised to the y power. And there's a little review of logarithms here that you can read. We have touched on this in the past couple of days, but I would highly recommend giving this another quick read through. And the math notes box at the bottom here, please put a box around or highlight the math notes box on your own paper. And note that at the bottom here, it says that the definition of a logarithm is very, very important and must be memorized. I would highlight that. The definition of a logarithm is very important and must be memorized. All right. So we're going to practice these things on the back of the worksheet. Looking at problem 3-68. Here they're just asking us to explain a couple of things. It says use the definition of logarithms to answer the following questions. For example, the log of base 5 of 25 equals 2 because 5 squared equals 25. So the log in base 5 of 625 equals 4 because 5 to the 4th power equals 625. Okay? So this says in problem 3-67 you express x as a function of y for the table. Now express y as a function of x. So in our table, we had said that x equaled 5 to the y power. So if we're going to express y as a function of x, well, y is our power, or it's the exponent, sorry, y is the exponent, so we can say y equals log in base 5 of x. Turning it around. Or you can say log in base 5 of x equals y. That would be correct also. So we're going to practice a couple of these in problem 3-69. 3-69 says the log in base 5 of 625. We have this already up on problem 3-68a, so hopefully you know that the log in base 5 of 625 is 4 because 5 to the 4th power is 625. So what is the log in base 5 of 125? And log in base 5 of 25. If you were unable to answer these before I wrote the answers up here, feel free to come see me during intervention and get any help that you may need. Pause and rewind or rewatch if you need to. And let's look at problem 3-70. Okay, so we're just going to fill in the blanks in a couple of answers here, or just kind of restate them. This says that logs will work for any base. Log in base 3 of 81 equals 4 because 3 to the 4th power is 81. Log in base 2 of 32 is 5 because 2 to the 5th power is 32. So we're just rewriting here. Log in base 2 of 8 equals 3 because 2 to the 3rd power equals 8. Try B, C, and D. Pause it. Try those problems and then check your answers. Log in base 6 is 1296 is 4 because 6 to the 4th power equals 1296, which you are welcome to check in the calculator. Log in base 4 of 1 over 49 equals negative 2 because 7 to the negative 2 power equals 1 over 49. Doing okay? And log of base 9 of 3 equals 1/2 because 9 to the 1/2 power equals 3. Remembering that the exponent 1/2 means square root. And 3-71. -71 says that each log equation can be rewritten as an exponential equation and vice versa. That's what we've been practicing. This is to copy each below. Well, they're already on your worksheet. You don't need to copy them. But you should rewrite them in the other form. The other form. If they're already written in log form, then you're going to write them in exponential form. If they're already written in exponential form, then you're going to rewrite them in log form. So the exponential forms we're going to start rewriting as logs. That's already in log form. This is an exponential form. This is an exponential form. So let's start with those, okay? The log in base 7 of y equals x because 7 to the x power equals y. Try C and D. Pause it and try them, then check your answers. You can use this as a guide to do C and D. Here we have log in base 11 of x equals y. And here we have log in base W of B equals K. Did you get them? If you're still struggling with this, feel free to bring questions to intervention and I'll be happy to help you. And for B, E, and F, we already have the log form. We're going to rewrite it in exponential form. Okay? Remember that the base of the log raised to the answer is the number raised to a power. So the base of the log raised to the answer equals the value. Okay? You can use that as a guide here. Two more down here. Here we have W raised to the K power equals B. Pay attention to D and E. Okay, and here we have 1/3 raised to the Q power equals P. One more thing for you. Pause or rewatch if you need to, and have a little assignment for you. The last question says to experiment with your calculator to determine what base the log button on your calculator uses. You may be able to guess that, but just a couple of quick checks on your calculator should confirm it. So what I want you to do is experiment with that on your own, but before I see you again, I want you to email your answer to problem 3-72 to my work email, my school email at jbrunets@madison-schools.com, and include your name in the email. Thanks for watching, and I look forward to your responses.